In this lesson, we're going to learn how to do basic stoichiometry problems. Very, very simple ones. We can use the information from our new mole island, which it has the equivalencies for us. We can also use the same information from here, which we set up the day before. And we're going to also use this information that I had you write onto the top of your notebook, page 105. These are basic directions for using conversion factors and the general formula for stoichiometry. First step is to list your variables. You have knowns, unknown, and you can have a singular conversion factor, or you might have plural. Next week we're going to have plural ones. This lesson will just be singular. The next thing you do is you write your known as a fraction, that is first, and then write the conversion factors as a second fraction. You're going to arrange your conversion factors so like terms cancel, and I have that in quotes because like terms for this is going to be units, which are things like grams and moles and milliliters, could be atoms and molecules, etc., right? And also like terms could be chemicals, and it depends on your conversion which one you're paying attention to. Chemicals are like water, CH4, CO2, NH3. You have to have those in there so that you know what to cancel. Then we're going to complete the math. We're going to multiply all the numerators, multiply all your denominators, and then divide the denominator into the numerator. And I'll have this, we'll come back to that off and on. Alright, this is how I'd like you to do this. These are one-step examples for conversions, which that's like a me term. It means that you're just literally going to have one conversion factor. It'll become clear as we go. I like this on page, your notebook, page 106. Yes, it might be better to turn your notebook. I do want you to write the question. They're not very long. I'm giving you a space to list your knowns and unknowns. Please do that in this separate space, and then a space to set up the solution. So again, this is on page 106. And we're going to go through 5 examples for this. Alright, I have them here. So this is the first example. And got extra space so that we need it. Alright, example number 1. I would like you to write the question, which is how many moles are in 25.6 grams of sodium hydroxide. The variables, the known is whatever we are given. So we have 25.6 grams of sodium hydroxide. The unknown is whatever we are looking for. So the question asks how many moles. So it's going to be question mark, mole, sodium hydroxide. The last part are the conversion factors. And you want to pay attention to your units here first. So we're going from grams into moles, and you can use either one of our resources to figure out what to use. Let's start with the mole island. We already identified that mass is grams, so we're starting in grams and then we're going to moles. And on the mole island, if I get a little closer, it reminds you that 1 mole is equal to molar mass. That is your equivalency in grams. We also know that could be atomic mass. So let's look at this other resource we created the other day. Right? Both my molar mass and my atomic mass convert grams into moles. So So I have to figure out now, for this particular problem, am I going to use atomic or molar mass? So I need to go back to the problem. In this particular problem, I have sodium hydroxide. That is going to be a ionic compound. I'll jot that down. Right, so this is an ionic compound. So because of that, I need the molar mass. Right? It's an ionic compound, so I need the molar mass. Well, I think I will figure out the molar mass for you right here. So we need the molar mass of NaOH. I have a sodium, an oxygen, and a hydrogen, 2299, 15.99, and 1.008. I am dropping the multiply for this particular one because I have one of all of them, so it makes my life a little bit easier. And I pick up my calculator, clear, 2299 plus 15.99. And the molar mass is 39.99, and that's grams per mole. And I might put the little 1 there for you, 1 mole. Alright, so this is going to become my conversion factor, right? So here are those fractions, conversion factors, molar mass over 1 mole, or 1 mole over molar mass. I'm not going to know which arrangement to use until I set up my problem, so I'm just going to jot down the conversion factor, and I might need to flip it. That's a possibility. So here I'm going to have 30.99 grams per 1 mole. Alright, last part of this is the actual setup for the problem. And it says known times CF, remember that's conversion factor, is equal to the unknown, and that is the same every single time. I'm going to set up a fraction, right? Remember this? We're going to write the known as a fraction. So the known is going to be a fraction times the conversion factor, which is also a fraction, and that's going to equal something. I'm going to put this as a 1 in black because the first conversion factor is always going to be a whole number. So everything here, 25.6 grams of sodium hydroxide. That is the known. Back to my green directions here, it tells me to write the conversion factor as a second fraction. I need to arrange so the like terms cancel, and like terms could be units or chemicals. So let's take a look. We have a unit and a chemical, but my chemical is staying the same, so it doesn't matter. Therefore, my unit is going to be my matching term here. So I have a grams here, right? Therefore, I want to put the grams on the bottom. So there's the grams, and the number that goes with grams, I'm going to bring it along. On top is going to be whatever is left over. Okay. Now if I take a look at this, grams of sodium hydroxide cancel, and I'm left with the unit that I'm looking for, which is moles. So then I go 25.6 times 1 is 25.6. Maybe I'll write that out. And the unit, 25.6. Now it's in moles. Sodium hydroxide. And 1 times 39.9. And the grams is gone. Now, I'm just showing you this. You don't need to do this intermediate step, but I'm watching a lot of you cross multiply, and we're doing something a little bit different than cross multiplying. I do have to pay attention to significant figures, and the significant figures depends on the first number. There are 3 numbers there, therefore I can have 3 significant figures. And therefore my number is 0.640 moles of sodium hydroxide. Right, so the question said, how many moles are in 25.6 grams of sodium hydroxide? And I just found the amount of grams of sodium hydroxide. If I had, yeah, right here, moles sodium hydroxide.